Welcome to Math with Mrs. Cox. We are on Chapter 7, Lesson 1, page 481 in your new math book. We are talking about numerical expressions. Let's begin. A numerical expression, such as 8 plus 7, is a combination of numbers in at least one operation. You can find the value, or evaluate, which means solve, the numerical expression by completing each operation. Let's begin. Gregory and his family went hiking over the weekend. On Saturday, they hiked 5 miles, and on Sunday, they hiked 5 miles. Use the bar diagram to write and evaluate two numerical expressions to represent the total number of miles hiked. And here they have drawn a bar diagram with 5 miles and 5 miles represented by two rectangles. So we can say 5 plus 5, and evaluate means we solve. So 5 plus 5 equals 10. Use the bar diagram to write a multiplication expression. As you can see up here, we added 5 plus 5. Well, multiplication is just repeated addition. So we can just say we had two 5s, and we can just write it as a multiplication problem. So 2 times 5 can also be written as 2 times 5, and evaluate or solve means 10. So they hiked a total of 10 miles. Mrs. Yearling has two groups of 5 students and two groups of 4 students. And here she has it shown, 2 groups of 5, 2 groups of 4. Use the bar diagram to write and evaluate two numerical expressions to represent the total number of students. So we can say 5 plus 5, because there's 2 groups of 5, and 4 plus 4. There, we have all the numbers that were talked about. Now we're going to transfer it into a problem that we can evaluate or solve. So 5 plus 5 and 4 plus 4. 5 plus 5 is 10. 4 plus 4 is 8. So we have 10 plus 8 equals 18. Using the bar diagram to write an expression, use multiplication and addition. Here we had 2 5s and 2 4s. So then we can write it as a multiplication problem. 2 times 5 is 10, and 2 times 4 is 8. Then we're going to do 10 plus 8 is 18. So there are 18 students that are divided into groups. I know this seems really basic, but it'll help you out in the next chapter. Number 1. Evaluate the addition expressions to find the sum. Does the order in which the expression is written change the sum? So if we did 7 plus 7 plus 5 plus 5, what would that equal? This would be 14 and 10. Add those together, it'd be 24. And over here we have 7 plus 5 is 12. 7 plus 5 is 12. 12 plus 12 equals 24. So does the order in which they are written change? The answer is no. Both equal 24. Number 2. Suppose Miss Yearling had also had another group of 4 students. So an additional group of 4 students to add to these other groups. Write 2 new numerical expressions to represent the total. Okay, well, if she had an additional group with 4, we would just say, well, she's going to have a group of 5, a group of 5, a group of 4, a group of 4, and another group of 4. And expression 2 is where we actually times it. So how many 5s do we have? We have 2. And then they want to know how many 4s we have. We have 3. So 2 times 5 and 3 times 4. And that's all we do there. It's not asking us to solve them. Caleb's music class is divided into 5 groups of 4 students. Here we have 1, 2, 3, 4, 5. 5 groups of 4. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of students in his class. Write and evaluate an expression using only addition. Oh, this one's going to be a long one, so we have to write 4 plus 4 plus 4 plus 4 plus 4. And let's see, that's 1, 2, 3, 4, 5. So 5 times 4 is 20. That took a lot of work. Now write it using multiplication. This one's going to be so much easier. 5 times 4 equals 20. Easy peasy lemon squeezy. 20 students in the class. Number 4, identify structure. Bailey's soccer team had snacks after the game that included 12 granola bars. Yum. 12 mini muffins and 14 bananas. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of snacks after the soccer game. Here we have our 12 granola bars, 12 mini muffins, and 14 bananas. So if we're going to use these numbers and write an addition, we're going to go 12 plus 12 plus 14. And I know 12 plus 12 is 24, so I'm going to add 14 to that real fast. 38 is my answer. Now we're going to write and evaluate. Do we have any numbers that are repeated? You're right, 12 and 12. So we can write it as a multiplication problem, by saying 2 times 12. But we're going to put parentheses around it so we know that we need to do that first. That grouping needs special attention and needs to be done first. Then we're going to plus the 14 to equal 38. So there are a total of 38 total snacks after the game. Sounds like my kind of after game party. Plenty of food. Number 5. Washa went bird watching and spotted 6 robins, 5 sparrows, 6 cardinals, and 6 doves. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of birds Washa spotted. Okay, so we have to just use addition. You're familiar with this. We just add the numbers up. 6 plus 5 plus 6 plus 6 equals, not sure why I did that button. So 18, 19, 20, 21, 22, 23 equals 23. Now, let's see, do we have any numbers that repeat? Yes, there are 3 6s. So for our next problem, we can say there are 3 groups of 6. We're going to put parentheses around that so we know that they're special and they can be grouped together. Then we're going to plus the 5 to equal 23. So he watched a total of 23 birds. Now looking at this, which one does not belong? Okay. The bar diagram can show 3 out of 4 expressions. Which one does not belong? So we need to count them up. I'm going to add them all up together. So 5 plus 4 is 9. Well, let's see, I'm going to do 1, 2, 3. 3 5s would be 15. Then I have 1, 2, 3 4s would be 12. So 15 plus 12 is 27. Okay, now this next one, oh yeah, 3 times 5 is 15. 3 times 4 is 12. Oh, that looks like the same. That's going to be 27. Okay, the third grouping. 3 plus 5 is 8, 9, 10, 11, 12, 13, 14, 15. This one's only 15. Unusual. Okay, last grouping. In the parentheses, we do that first. So we have 5 plus 4 is 9 times 3 is 27. So which one does not belong? This one. does not represent the bar diagram. And if you look, you can also see 3, 3. And we don't have any 3s there, do we? And write about it. How can bar diagrams be used to model numerical expressions? There we go.